Well, we have this function in here and we have to graph it. Y equals 2 sine of 4x minus pi. What is the first thing that we have to know? Well, I always like to think at the normal, I would say, the normal charting of the function. It's always good to have that in mind. And you know, for the sine, we just have this. And this would be y equals sine of x. The first period, this would be 2 pi, and here would be just pi. The first thing that we have to know is to have in mind what is the basic function. Once we know this, let's see what happens to this function. And for this is going to change the amplitude. Well, usually we know that the sine goes, I didn't write in here, let's also put it, 1, and this is minus 1. This is the amplitude. The amplitude is 1, okay? Some people say the amplitude, it is 2. No, it's not. The amplitude, it is just from this point to this one, okay? It is just how tall it is in this way. So this is the amplitude. So the amplitude now, it is going to be twice as much. For that, the amplitude would just go to the 2, then minus 2, plus 2, minus 2, and so on. What about this one? Let's change colors. What about this one in here? Well, this one is going to change the periods. We're going to shrink or amplify in this way, okay? The function. So this is going to change the periods. And this last one, let's take the red one. This is going to deal about the phase. The phase. What about the phase? This is A, okay? Phase. The phase is just like take the entire curve and move everything to this part or everything to these parts. Okay? Okay, and now just to illustrate a little bit, let's just go to this chart in here. I'm just going to show you what happens when we just change the parameters. So this is our function, basic function for the sine, okay? And as you can see, this is our period, okay? This is our period, 2 pi, okay? Half period, just pi. What is the period? Just recap. The period is the one full cycle. If we just start going up, down, okay, this is going to be the first cycle. So this is one period. What happens if we just touch the amplitude? Look what is going to happen. We are going to still have those roots in the same place, pi, 2 pi, but we are only changing the amplitude. If we just put 4, it is going to be even higher. If we just put 2, 3, 4, 5, and so on, okay? Let's leave 3. This is when we just change the amplitude. What is going to happen when we just change the period? Now I'm going to take the charting to explain something. If we are multiplying here our x, our period, it is going to be divided. It is always the opposite. This goes even for the phase shift. but let's just discuss first the period. Okay, if we're multiplying the x, this means that our period it is going to be shortened. Can you see? This is 5 is shortened. If let's start 2, you can see that the full cycle ends at pi, but our initial cycle was finishing at 2 pi. Okay, our initial cycle ended here. Now, because we are changing the periods, instead of our blue curve having the first period at 2 pi, the period now is going to be halfway. Why halfway? Just because we just have to divide by 2. And if we go to 3, you see, 4, 5, maybe 9, can you see? The bigger we multiply the x, our periods, it is divided by this same ratio in here. Okay, let's just live with 3, 5 I believe. Okay, and what happens when we just deal about the phase? It is this plus 1. Again, it is always the opposite. Like in here, if we just multiply the x, our period, it is divided by the same 5 in here. In the same way, when you are talking about the phase, when we just add a plus 1, we are just taking a minus phase. We are just shifting to the left. Okay, here. Try to see that the curves are the same. Let's just shift very little. 0.3, 0.2, 0.1. You see, the curve, it is the same. It is the same curve because we are not changing on the amplitude or neither at the periods. We are just changing the phase. The phase, it is exactly the same curve, but we are just grabbing this curve and moving to the right or to the left. If we have a plus in here, we are taking our curve to the left. It is always the opposite. Now let's see, plus 0.1, 0.5, 0.7. Okay, now plus 1, plus 2. Okay, and for that, just pick a point. Let's take this point in here. Just look at this part of the screen and see how our green function goes to the left as I add more values in here. This is a plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, can you see? Plus 8 and so on. Let's leave it with plus 1. And what happens if instead of plus I just make a minus in here? What is going to happen? Minus means that it is the opposite. We are going to the right. Plus, we are going to the left. And a minus, we are going to the right. Look, as soon as instead of putting a plus in here, put a minus, what is going to happen? Our green curve is going to jump to the right side. Look, you see? Okay? So it is the opposite. Whatever we are adding here, we are just go backwards. Whatever we are multiplying in here, we are just take our periods and we are shrinking. Everything is the opposite. Okay? For instance, of course it's the same because the black and the blue are the same. Now let's just divide by 5. No, by 5 is too much. Divide by 2. Look, if I'm dividing the period by 2 in here, it means that what we are actually doing is we are just taking the period in here and we are just multiplying by 2. Divide by 2 the x, the period is multiplied. It is always inverse. Okay? So let's leave it with 5. And in the end, we have taken the amplitude 3 times as much. Can you see? It lands at 3. The normal function lands at 1. Then we have reduce it, okay, shrink by a factor of 5. Then we have shifted to the left. Why? Because a plus in here. And in the end, what did you do? This is our chart. Amplitude 3 times as much, periods 5 times shorter, and the phase to the left. Okay? This first exercise where I just use a little bit the charting, okay, at the computer, so we can just see the theory in a more intrinsic way. Now because to solve the exercise is very simple. Now let's just start solving the exercise. Well, what is happening to the amplitude in here? I'm just going to write the first letter, okay? Amplitude. Our amplitude, it is being multiplied by 2. Then our period, what is going on with our period? Our period is going to be divided by 4, always the opposite, remember? And what is going on with our phase? Yeah, I have to write phase because it's P and P is not going to help. Our phase, if there is a minus in here, so we are going to add a plus pi, always the opposite. This is our period, okay? And this is the amplitude. Well, once we know that, the next part that we do is this. If our period, it is going to be divided by 4, I just like to put in here what happens. What are those steps? 0, pi, 2 pi. I'm just going to write those in here. 0, pi, and this would be 2 pi. This would be the normal. This would be the normal function, but we have to divide by 4. So let's divide by 4, everybody. Okay. So what happens is now that this length in here, instead of being from 0 to pi, it is going to be from 0 to pi over 4, and that's it. Once we have done this, now our charting, it is done. Okay, this is x, this is y. Let's always name everything. Now, okay, let's put the places, the roots. Okay, what are the roots? The roots are when the y goes to 0. Okay, this is going to be 0. Then maybe one here, one here, one here. Okay, enough. Later we just deal about the negative. Okay, now it's 0 to pi over 4. Why? Because initially we had from 0 to pi, remember? But now we have to divide by 4. Why? Because if we have a times 4 in here, it means on our charting is going to be a division by 4. So this is going to be pi over 4, 2 pi over 4, 3 pi over 4, just pi. And again, minus pi over 4, and so on. Now let's just write the points in our chart. Now, well, the chart is basically done, but we could go into this way, or we could go into this way. So, are we going to start upwards or downwards? And there is a very simple trick. It's not a trick, okay? Let's again use our sideways notation. Let's draw our trigonometric circumference. This is the cosine axis. This is the sine axis. Okay? Now, what is going on in here? We are at 0. We are trying to see if we are going into the positive y direction or into the negative y direction. Well, let's see. Let's hide x equals 0. What is going on? When x equals 0, this is 0, right? So it's going to be a sine of minus pi. That's where we are when we are at x equals 0. And what is minus pi? Remember how we count angles. Angles, we always go counterclockwise, okay? So this is going to be 0, okay? This is going to be 45, 90 degrees, and so on. Angles grow in this way, okay? And this would be the angle, okay? So this is the positive direction. What is minus pi? Well, we just start at 0, and this is where x equals 0 for our function here. So x equals 0, we just start in here at minus pi. Remember how we grow angles? They always grow into the counterclockwise position, and they're going to start like this, okay? They are not going up. We always go in this direction, always counterclockwise. So now we're going to do this. We have to. This is our direction, okay? This is how angles grow. Look, we start at x equals 0. At x equals 0, the sine is 0, right? That's our first point in here. X equals 0. Now, what's going on? As x starts to grow, as our function starts to walk, the sine is going to be negative. So there is only one way that we can chart this. And this is the way we have to chart. And so on. Now, and so on. Okay. Again, why this is negative? It must be negative. Okay, it must be because we are going into the negative side. Why are we going into the negative side? Make this 0. We start at pi. Plus or minus pi, it is the same. It means that we are going to start at this point in here. From this point onwards, the sine is going to be negative, because remember, when we are at the third and fourth quadrants, the sine is negative. So our sine is going to start to be negative, and when we get to this point, it's going to be 0, and then starts to go to the highest, and then again, and so on. Okay, and of course we have to put the amplitude in here. This is 2, right? Okay, this is a +2, this is a -2. Okay, and that's it. There is anything else that we can do, and the exercise is solved.